We've talked about what we're putting where, talked about the boxes being in place. Now we got to run the wires. You get to your wire size. And I'm going to do 3 different groups of that we're going to talk about. So rather than trying to explain all that to you now, I'll do that as we do the circuit, as we wire the circuit. So I think slowing it down a little bit, and we'll just come and wire some stuff. So let's go do that. What I'm going to do now is I'm going to demonstrate how we terminate the metal clad cable. Again, this isn't what you'd be doing in your house or anything like this, but in a commercial situation, we'd be using this kind of stuff. And when we're all done, this will be neater than what you see here. It's more complicated because of the way I built this trailer, but it's prototype. I have plans for the next one that are going to be a whole lot better. So basically, we've ran our circuits beyond this, and then at the beginning of every circuit, there's a wire that we call a home run. So this is the beginning of this circuit. This circuit goes from here, then it comes over to here, it goes to this box here, goes up through the ceiling, back down into the wall, and then it goes to an outlet, the outlet right there underneath. That's the complete circuit. That's all I have on that circuit. And then it comes from here back into the breaker box. So that's what we're going to call our home run. So by connecting that wire to the breaker, when I flip the breaker on, each one of those boxes I showed you will power up. So what I'm about to show you in detail right now is how we terminated each one of these. So each one of these metal boxes has plugs in it. You knock out the right size plugs. So you'd knock this plug out right here, and that's going to leave you with a hole that this inserts into. This isn't the cheapest way to do this, but it is the easiest way without having to buy a bunch of rigid materials and cutting things to perfect lengths and all that. So a lot of times in commercial work, I'll use this when I'm just adding a quick little outlet somewhere, something like that. I wouldn't wire an entire massive commercial building with this because it would be way more money than conduit and then running multiple wires in the conduit and all that. But in this case, again, it just makes more sense because of how hard it is for me to get around in this trailer. So we went with the metal clad cable. These ends here will literally just pop onto here. After I strip this, it'll pop onto here, and then this will pop right up into the box. And that's how we connect it. Same thing happens on our breaker box end. Now, something very important here that you need to remember is you're gonna strip this. So when you're running your cable, you have to make sure you understand this is my wire length. So I could stop my wire length right at the breaker box there, and I could connect this up and it'd be connected, but there'd be no wire continuing on, and the wire is what you need. So it's important that you run enough extra wire that you have the wire you need to work with even after it's mounted to the box. So I'm gonna strip this cable right now, but I'm going to do it way up there at the breaker box, and then I'll have wire hanging way down here. Then when I wire up my breaker box, I'll trim my wires to the appropriate length. So this is a 110 circuit. So rule of thumb for me is I'd like the wire to be about a foot longer than the breaker box. So if I'm coming from the bottom up, I want to mount it and have my wire be hanging up there a foot higher than my box. If I'm coming down, I want it hanging a foot lower. So this is right here is where I'm going to strip it. And I've already showed you this a little bit. You got the wheel in there, you line that up, get it in place, and you just crank that, and when it gets easy, you know you've cut through. The problems that I was having are all about this adjustment. So if you're not cutting all the way through it, tighten this up more and get it to where it cuts through there. Then you just take this, to take it off, you basically just slide it back, and then that'll come right off. Pretty sure this one's a Greenlee, which is a good tool. I'm really happy with it. This is a little older. They look a little different now, but it's a Greenlee flexible conduit cutter. And I'm pretty sure you can get them at Home Depot. Definitely get them online. Amazon would have them, stuff like that. So Now I gotta find my cut. Where's it pulled? There it is. So you can see it just cuts that and pulls off there. You can kind of see a little dash in the side of it there, and that's all it does. It just cuts that in one spot so it pulls apart. These have these are just your 3 wires, and they got a plastic coating around them. I'm a little bit weird, so what I'll try to do is I try to preserve that plastic. It's just another layer of protection when I pull it through and then cut the plastic off after I put my connector on. So I'll go right over the top of this plastic here. Those there, you want to get these. Again, it's just another layer of protection. I'll show you in a minute. The connectors actually have it, but when you cut this right here, this is really thin metal, so it's sharp, and you don't want your wires to ever rub through or anything. So you snap this on the wire like this, and you push it inside this, like that. And now you can kind of see it's got right there at that sharp edge, it's got that nice plastic protector protecting it. Then you grab your end, and this is a little hard. If you struggle with it, just take the plastic off. Like I said, this is just a me thing. That's not necessarily required. But see, I was able to keep that plastic on there now, so I can just pull this up here. And then you want to just basically press this until it pops in place. It's not real easy, but not real hard. Just press on it. And now I'll take and I'll cut I got this clear wire on here, this clear plastic on here that I preserved. So now I'll just take and cut that, and that'll just come right off there. So now, again, just like on the boxes, your breaker box also has holes. So I'm gonna run right through the hole, and just like this popped onto this wire, it'll now pop right into the breaker box. Catch that? I just pushed that in there. Now you can see I got my 3 wires here. This is basically one circuit complete, and this completes the rough in for the breaker box side. So what I mean by that is I won't mess with this wire again until I'm firing the power up in this building. So the drywall can come in, the insulation can come in, all the flooring will probably be in, all kinds of stuff comes in. Bottom line is I had to get my wires in the wall before I could insulate, so I'm just doing a rough in. So what I do now is I just take and I fold these, and I just kind of stick them into the breaker box. And before I spray my insulation in here, I'll cover this up so that I don't spray insulation all over my stuff. And there's a few things that you should really be careful of if you don't know anything about electricity. Grounding is very important. As far as the finished project and safety of others, I don't think there's anything more important than seeing to it that you properly ground everything that you do in electricity. That's what will save people from touching something that isn't supposed to have power and having it have power. The next thing would probably be choosing the right size wire. Now we're going to talk not so much about electrocuting, we're talking about fire potential. Fire would be the wrong size wire. If you have a wire that's only supposed to carry, 20 amps and you run 40 through it, or there's a short or something, if you don't have the right size wire, you can literally melt your wire and start a fire before your breaker blows. So it's very important that your wire is sized to your breaker. So if I have 15 amp wire, I need to have a 15 amp breaker. And that way this wire can never fail and start on fire. The other fire hazard is bad connections. If you connect these wires to an outlet and you have a loose wire, what happens is that wire is going to arc. So a lot of times you've probably seen, like when you plug something in that's turned on, you'll get a spark at the outlet, or you just probably have seen sparks before. That happens when you have something that needs power and then you have power. As those two things get close together, when they almost touch, that power will jump across those 2 points. So if you have a loose connection, that jumping, that arc is happening a lot, and it can actually cause fire. So good connections, making sure they're good and tight, they're solid, having the right sized wire, and then make sure everything is grounded very well. Those would be the biggest tips that I would give anybody that's doing this. Obviously you shouldn't mess with electricity if you don't understand it. I'm never going to tell anybody not to do anything themselves. It's what I'm doing. It's what I've always done. But I will tell you that I never do anything that I don't understand. If I don't understand, I dig in, I learn, I talk to people. It's what my dad taught me to do. And I learned how to do it the right way. And with electricity especially, plumbing, yeah, bad things can happen. You can have floods, you can make a mess, but electricity, you can get hurt and you can hurt others. So take the time to make sure you know what you're doing before you do it. Phase 1 of your rough-in would be basically building your circuit. Phase 2 is you bring your home run back to your breaker box. You get your wire in your breaker box and you've completed your circuit. That's it. Now we don't do anything. When we come back later, we'll put our outlets in, we'll put our switches in, we'll do all that.